Now, from today onwards, I will be taking your attendance and I will be very strict in your attendance because attendance also has some internal marks. You are already explained, or you must be knowing how the mark division is done. We will, for this paper, you have to appear for 100 marks, out of which 50 marks will be internal type and another 50 marks you will appear in the end step. You are strictly told to join from your kit mail ID only. So if you are trying to join from any other mail ID, you will be denied entry. If you are having some problem with your kit mail ID and because of which your kit mail ID is not in operation, you can write to me from via mail, and where you will keep your tutor mentor in CC. The tutor mentor will endorse that yes, this boy is having or girl is having this problem with his kit mail ID, so allow him with the other mail ID. Then only I will allow you till the problem with the kit mail ID is resolved. But as long as no such request from tutor mentor is coming, I am not going to entertain anyone who is trying to join to the Google Meet from another mail ID other than the kit mail ID. You see 852 Aman Kumar is trying frequently to join to the class. I am denying entry. If any one of you know him, please call him and tell to join from the kit mail ID. If it is not having the same, then he should write a mail now to me with the mail ID from which he wants to join. Then today I may permit him, but from next class onwards, his tutor mentor should request me to put him or allow him to the Google Meet. Any one of you, if you know him, 852 Aman Kumar, tell him please. Okay. Second thing is, I am going to select someone among you who will be coordinating among us. I mean, when I am taking attendance, suppose someone's mic is not able to unmute. In that case, he may write in the chat box. So he, who will be the coordinating person, you can tell him the class representative for physics theory and lab class. He will let me know immediately, sir, he is not able to unmute, so please give him attendance. Because once the attendance is over, it will be put in the sub portal. And no change will be entertained after that. These are few things you have to take care. So from his own side or her own side can come forward to act as the coordinator or class representative for physics theory and lab class.
Sir, Shivam.
Shubham.
Shivam, sir.
Shivam. Who is Shivam? Who is Shivam?
Sir, roll number 749, sir, Shivam Kumar.
749, are you there?
Yes, sir, I am there.
Do you agree with this proposal?
Yeah, but I need 745, sir. Because there is a need of backup, sir. If something happened with me, there I need a backup, no, sir. 745.
Okay, then 749 Shivam Kumar, 745 Satyavata. So others, you please comment. This is a proposal. If you all approve, then I will put them as class coordinator to tell from your side.
Yes.
Others, anyone having any complaint or anything?
No, sir.
No, sir.
No, sir.
No, sir.
And others? Another one, Aryan Prasad, he is also trying from a separate mail ID and not permitted to show. I am denying him entry. Anvay Ghosh, 775, he is trying to do the same and I am denying entry. So please, if you they are your friends, please tell them if they want to join, they should write a mail to me mentioning their mail ID from which they want to join. Then only I will give entry to them. But next time that appeal should be endorsed by the tutor mentor. Now there are how many students are there in this section? Let me see.
Sir, total 92 or 93, sir, total.
Let me see. Arey, tell Anway goes. I am not going to admit him from other ID as long as his tutor mentor or he himself is not writing mail.
Sir, he wrote
Yes,
that
sir.
first he joined KIT ID, sir. Then he unable to. First he tried from KIIT ID, sir, but he unable to join at the call. He said and he sent the screenshot, sir.
Yes, sir.
told him
Aman
to
is
check.
trying from his kit ID only.
Okay. Today you can now tell him I will admit him. Who is he? His name is.
Aman.
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 852.
But now
852.
trying is Aryan Prasad. Do you know Aryan Prasad 871?
Yes, sir. Yes, sir.
He is also
Yes, sir.
facing the
He's
same problem,
also.
sir.
He's
Okay,
also trying to join,
today
sir.
for I am admitting him. Today for I am admitting him, but tell him that next time, sir, please let me 775. Tell him to join 775. We are having some bad experiences with this, admitting everybody to the class.
Yes, sir.
And that is one thing
Yes,
because
sir.
of which I am choosing. Actually, see, the discipline of this class is not my responsibility alone. Me and my children, you people, we all together will try to maintain the discipline. Now, what
Sir.
he is writing, sir, I cannot join the meet because he denied, perhaps he is not able to, na?
So he is trying
Yes,
from
sir.
kit mail also.
Sir, yes, sir.
Sir, you denied him from his personal ID 2 times, so he's got banned from that ID. So he can't join from this again.
Sir, he
Then I
was
am
actually
sorry.
trying from his own kit email ID. But
Okay. But that you should have told because we have some past bad experiences. I should not tell you, but you might be also knowing what they do. They enter from any mail ID and we never, we spend so much time in tracking them. And what they do, they write, rubbish things in the class, thereby disturbing your attention.
Then, sir, we can do that before joining. If our kit mail ID doesn't work, before joining, we will WhatsApp you our another mail ID from.
No, you
this
write
mail.
a mail. You write a mail, please. Immediately you write because when I take the class, I used to open the mail ID also. My mail ID. So you write a mail. You have my mail ID?
Sir, please again share it in the chat box.
Okay, I am sharing.
Okay.
Now he is writing. You cannot join to the call. What I can do? I am very sorry. Aman is writing. I am not able to help him. Tell him to join from another. Try joining from his mother's ID or papa's ID so that I can permit him for the timing. Next time I will change the class Google Meet ID. Google Meet link. So now I posted my mail ID. Next time you interact through this. Tell him to join from another mail ID so that I will admit him. But remember this thing, I am sorry. And particularly Shivam and Satyavrata, you have to be expert enough in this regard to locate and identify who is doing the mischief. Because whether I should respond to all your queries in physics and science queries, or I should look into that only. So it is
Yes, sir.
our whole responsibility taken together. We all are from cultured family. We do not want Aman Kumar now enter. Okay, I am admitting. Aman Kumar. Aman Kumar.
Yes, sir. Good afternoon.
गुड आफ्टरनून। सी बेटा, तू अगर पहले से लिख दिया होता कि मैं इस मेल आईडी से ज्वाइन करूंगा, मेरा किट मेल आईडी वर्क नहीं कर रहा है, तो मैं तेरे को परमिट कर देता। अभी नेक्स्ट टाइम अगर ऐसा होता है तो व्हाट यू पीपल शुड डू, यू शुड राइट ए मेल टू मी विद द मेल आईडी फ्रॉम व्हिच यू वांट टू ज्वाइन, and that should be endorsed by your tutor mentor. I mean, when you are writing mail to me, you keep your mentor in CC. The mentor will endorse that yes, he is having a problem with his kit mail ID, so permit him to attend the classes till the kit mail ID is not rectified.
Sir,
Okay,
sir,
I am
it's
sorry, Aman. I am sorry, very sorry.
no, no, sir, no, sir. Sir, it is working. Only like the previous class I attended from the kit mail ID only. ये वाला class
Then-
पता नहीं क्या हुआ. Sir,
Okay,
I
then-
joined from the kit mail ID. It's writing that you can't join this meeting. You can't join
Aman,
this meeting.
Aman, you have joined classroom?
Yes, sir.
Then
Sir, classroom से ही मैं join किया. Classroom में join
you are in
किया.
the classroom now, Aman.
Yes, sir.
Then why there should not be any problem? Okay. Okay, we should not spend more time. So, Shivam and Satyavrata, you know your responsibilities now, na?
Yes, sir.
Okay, thank you very much. So, I am going to take the attendance of this section. I will be strict little bit in attendance. So, you attend the classes regularly. Today onwards, I need not have to tell all these things again and again.
Sir, one student also facing this problem, sir, and where goes, sir?
So, who? If he wants to join
Sir.
now, I can admit with your
Sir.
recognition.
And where goes, sir? Sir, sir, he messaged you on WhatsApp, sir. Same
No,
problem.
that is true, but tell him to join from another mail ID so that I can admit him now. If you are
Okay, sir.
letting me know from the beginning that I am going to join from a different mail ID, then it's okay. Because I don't want any kind of disturbance during the class. Irresponsible and uncultured comments. Those are we have to keep ourselves protect now. We all now a team. Anything happens to one means it happens to the whole class. So that feelings we should have. If we will not have that kind of feelings, then we cannot build up the team. We have to be little bit strict about the guidelines. Okay. So 742, Samriddhi, respond your role. Samriddhi, are you there? 742? 2105 742.
Yes, sir. She is there, sir. In chat box, her name is showing.
Okay.
Her mic is also on.
Then 744 Satyaprakash.
Yes, sir.
745 Satyabrat.
Present, sir.
746.
Present, sir.
47.
Present, sir.
48.
Present, sir.
49. 49. Shivam Kumar. Shivam, are you?
Yes, sir.
This is Anway Ghosh. Do you know him, Anway Ghosh?
Yes, sir.
Yes,
Should I
sir. Yes,
give-
sir. That's the student.
Okay.
Yes, sir.
I gave him entry. Tell Anway also to do the same thing what I suggested. Okay. Shivam, 749.
Yeah, sir. I have told him.
Shubham, 751. Shubham, 751.
Yes, sir. Present, sir.
751, 752. Please respond quickly. So many students are there.
Present, sir.
753.
Present, sir.
आपको रोल नंबर आने से कुछ सेकंड पहले ही आप अनम्यूट कर दो सो दैट आप रेस्पॉन्ड कर पाओगे क्विकली. 753 सौभाग्य.
Present, sir.
55.
Present, sir.
56.
Present, sir.
58.
Present, sir.
61.
Present, sir.
53.
Present, sir.
54. Vaishnavi. There are two Vaishnavi. One Vaishnavi is in B6.
Present, sir.
Your duplicate is there also in B6, you know, OB6 online, offline class. He used to ask so many questions and very good questions. Okay, Vinita,
Present, sir.
767,
Present, sir.
770,
Present, sir.
71,
Present, sir.
72,
Present, sir.
73,
Present, sir.
75,
Present, sir.
76. You are
Present, sir.
responding little late. Be fast. 78,
Yes, sir.
79,
Present, sir.
80,
Present, sir.
83,
Yes, sir.
85,
Present, sir.
86,
Present, sir.
89,
Present, sir.
90,
Present, sir.
91,
Present, sir.
92,
Present, sir.
93, 93 Dabjyoti. 793 is absent. 97,
Present, sir.
98, Hitesh.
So his mic is on also, sir. He is present also.
Okay.
Yes, sir. He is present.
Okay. 799,
Present, sir.
801.
Present, sir.
लेट कर रहे हो बेटा, कुछ फ्रैक्शन ऑफ सेकंड टोटल मिल के 2-3 मिनट लेट कर देगा. 802,
Present, sir.
3, 4,
Present, sir.
7,
Present, sir.
8. Pallavi,
Sir, she is present. Written on chat box.
8, 10,
Present, sir.
11. Okay, 12,
Present, sir.
14,
Present, sir.
15. Ranjoy, 815 is
Present,
absent.
sir. Present, sir.
Okay, present. 16,
Present, sir.
17,
Present, sir.
18. Rishab, absent. 19,
Present, sir.
20, 21,
Present, sir.
22,
Present, sir.
23,
Present, sir.
24,
Present, sir.
25,
Present, sir.
47,
Present, sir.
28,
Present, sir.
29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32, 35, 35 Suvam, 36,
Present, sir.
38,
Present, sir.
39,
Present, sir.
40,
Present, sir.
41,
Present, sir.
43,
Present, sir.
48,
Present, sir.
49, 849, 51,
Present.
851,
So she is present. Say it too.
Present.
Anchal, okay,
Present.
852,
Present, sir.
853,
Present, sir.
854,
Present, sir.
55, sorry,
Present, sir.
56,
Yes, sir.
57,
Present, sir.
59,
Present, sir.
859, किसका?
Present, sir.
ओके, आपका बैकग्राउंड में नॉइज हो रहा है. 860,
Present, sir.
61,
Present, sir.
63,
Present, sir.
64,
Present, sir.
67,
Present, sir.
68,
Present, sir.
69,
Present, sir.
70,
Present, sir.
71,
So he has written.
71 is present. 71 present, sir.
yeah, 73, 75,
Present, sir.
76.
Present, sir.
Okay. So the absent students are 793, 818, 835, 849. These four are absent. Okay, thank you. Now, some of you might have opted for changed your option and might be planning for attending the offline classes. Very few of you, I don't know. But till you do not report to the university, you have to attend these classes, online classes. Okay. After that, if the competent authority make any changes, that will be incorporated. With this message, I am returning back to the topic that we had used. Actually, you mark, now it is 1:24. That means 24 minutes we have lost. While even if I teach for 1 hour, maybe 3 persons, Soham, Chavi and Suprasad. Do you want to say anything? 831, 792, and 838. Do you want to say anything?
No, sir. No, sir.
Then you have kept your mic on mute. Chavi is no, they're not there. She had left. She had left her place. Now, when I called, only she came.
No, sir, I was thinking, what are you asking about?
Whenever I call you people, if you are not responding, it will be interpreted that you are not present in the class. You left the class just after logging in, and that is a very, very bad habit. So I hope you will not do that. Okay, let me start. I am teaching two sections simultaneously. One is B6, another is B17. After the end of each week, I will compare and see whether both the sections are running parallelly or not. I have a work plan, and according to that plan, I have to cover the syllabus. So if I find that my syllabus is not covered to that much what is supposed to be covered by the end of that week, I may request you for one extra class. I will try avoiding that, but if it is not possible, as long as I am addressing your questions, that may be required. So let us come to the topic. In the last class, we discussed what is periodic motion. We characterized the periodic motion. Every periodic motion is characterized by two parameters. One is the time period and another is the frequency. Frequency is the reciprocal of time period, and every periodic motion has a time period. Now, all the periodic motions are not oscillations. Only those periodic motions which are to and fro type, they are only oscillations. So, oscillation is a subgroup of periodic motions. Now, oscillations can be categorized into two groups. Luna, class difficult. Oscillations can be categorized into two groups, as we have discussed in the last class. One is translatory type of oscillation, where the center of mass displaces from one place to another during oscillation. And second is the rotatory type of oscillation, where during oscillation, the center of mass does not displace. This translatory oscillation again is categorized into two parts. One is linear oscillation, where to and fro motion takes place along a straight line path. And another is curvilinear oscillation, where the to and fro motion takes place along a curved path. And about rotatory oscillation, I have also told you that it is a to and fro type motion, but the center of mass never displaces. Now, then we discussed in the last class about the simplest oscillation, that is the linear oscillation. We wanted to characterize linear oscillation. Now, when I say we want to characterize, what I mean? If I take two students among you, say Asif and Somyadeep, or say Ashish and Kunal. Now, you both are human beings, both are young, but you have some difference in your characteristics, you know. So, Kunal has a different height than Ashish. Kunal has a different mass than Ashish. Kunal has a different age than Ashish. So this age, height, mass, these are some of the characteristics by which you two can be distinguished. The same thing I am going to do in oscillation. What are the important characteristics using which I can distinguish one oscillation from the other? So to identify those characteristics and the corresponding physical quantities to quantify them, as I have told you, every characteristic can be quantified by the use of a physical quantity. So what are the characteristics of any oscillation and how to quantify them, how the physical quantities can be constructed to quantify them, we started discussing about it. We started with a linear oscillation. Now, as we know, in any linear oscillation, there are two experiments. Suppose x and y are the two experiments. A particle moves from y to x and has to return from x. So the velocity of the particle at x should be 0. But velocity if it is 0 at x, then obviously the particle will not move towards y. But in oscillation, the particle has to continue moving from x to y and y to x. So motion from x to y will be possible even if velocity at x is 0 if there acts a force on it. So existence of a force for possibility of oscillation is essential. Without an external force, no oscillation can be possible. That is what we discussed in the last class. But if this force will push the particle towards y, the velocity will go on increasing because it will be accelerated. And due to inertia of motion, it is going to be exceeding y. But what we want? We want that the particle has to return back from y. This will be possible provided the velocity of the particle at y is also 0. So what should happen? A force is required so that particle will move from x to y. But if the force accelerates and increases the velocity, then the particle will overshoot y. But y is an extreme angle. So this will be possible provided there exists a point O in between after which the force reverses its direction. That means for every oscillation to take place, an external force must be associated. When I say external force, I mean that the oscillating particle itself cannot be the cause of that force. It must come from the surrounding. Then only it will be an external force. So any particle wants to oscillate, association of such an external force is essential, and the force should be such that it will be pushing the particle going away from O towards O. जब भी पार्टिकल O से दूर भागने को कोशिश करेगा, ये फोर्स इस कैरेक्टरिस्टिक का होना चाहिए कि ये फिर पार्टिकल को O की तरफ खींचेगा. So O appears to be an equilibrium position. In fact, it is a stable equilibrium position. And the force that always tries to bring back the body to the equilibrium position, that is what we call as a restoring force. What we concluded, for any oscillation to take place, existence of a restoring force is essential. Without a restoring force, the oscillation cannot be possible. Now, there is a point O, which is the equilibrium position, and every oscillation has an equilibrium. Every oscillation. You look at any oscillation of nature, you will find a point position where the particle is in equilibrium, and the restoring force always wants to bring back the body towards that point. In fact, for oscillation, 3 agents are to be involved. Come to an example. Suppose you have a simple pendulum. You have read about this. Now take the simple pendulum to outer space where there is no gravitation. अब सोच लो, सिंपल पेंडुलम को आप आउटर स्पेस में ले गए जहां पे ग्रेविटेशनल फोर्स नहीं है. क्या आप उम्मीद रखोगे कि उस सिंपल पेंडुलम को अगर डिस्टर्ब किया जाए तो वो ऑसिलेट करेगा?
नो सर.
क्यों नहीं? क्योंकि उसको रेस्टोरिंग फोर्स प्रोवाइड करने वाला कोई एक्सटर्नल एजेंट उसके साथ जोड़ा नहीं है. जब उस सिंपल पेंडुलम को लाके आप यहाँ पे अर्थ के पास झुला देते हो, तब क्या होता है? ग्रेविटेशनल फोर्स अर्थ भी उसके साथ इंटरेक्शन में आ जाता है, तो ग्रेविटेशनल फोर्स उस सिंपल पेंडुलम के साथ जोड़ जाता है. सो ऑसिलेटिंग पार्टिकल एंड ए रेस्टोरिंग फोर्स प्रोवाइडर, पहला चीज जो चाहिए ऑसिलेशन के लिए, ऑसिलेटिंग सिस्टम जो ऑसिलेट करेगा. दूसरा क्या चाहिए? रेस्टोरिंग फोर्स प्रोवाइडर जो आउटसाइड एजेंट है, वो जोड़ के रहेगा इंटरेक्शन के थ्रू. अभी आप लाए उस सिंपल पेंडुलम को और झुला दिए अर्थ के पास, क्या सिंपल पेंडुलम अपने आप ऑसिलेट करने लगेगा? आप एक सिंपल पेंडुलम लाए, झुला दिए, बस. Do you expect the simple pendulum will start oscillating by its own?
No, sir.
Then what? Only if the gravitation is there, he will play the role of restoring force. So what we discussed here, an oscillating particle is needed, along with that a restoring force is also needed. And they are there, the oscillating system is the simple pendulum, and the gravitational force will play the role of restoring force. So even if restoring force and oscillating system are there, why not oscillation is going on? क्यों नहीं हो रहा है? अब बोलो.
External.
सर
क्यों नहीं हो रहा है? ऑसिलेशन, जब ऑसिलेशन होता है ना, पार्टिकल इक्विलिब्रियम से भटक जाता है, डिस्टर्ब हो जाता है, और ये डिस्टर्बेंस होने के लिए, पॉसिबल होने के लिए, वो सिस्टम कुछ एक्सटर्नल एनर्जी नीड करता है, जिसको हम बोलेंगे ऑसिलेशन का एनर्जी. किसी को भी ऑसिलेट करने के लिए इक्विलिब्रियम में जब वो अकेला रहेगा, जितना एनर्जी उसके पास है इक्विलिब्रियम में, वो चुपचाप बैठेगा, जिसको ग्राउंड स्टेट बोलते हैं. उस टाइम में उसके पास जितना एनर्जी होता है, अगर उसके ऊपर और कुछ एनर्जी नहीं दिया गया तो वो इक्विलिब्रियम से डिस्टर्ब नहीं होगा. ऑसिलेशन रेस्टोरिंग फोर्स होते हुए भी पॉसिबल नहीं हो पाएगा. इसीलिए फॉर ऑसिलेशन टू बी पॉसिबल एन एडिशनल एनर्जी इज नीडेड. उसी एनर्जी को ऑसिलेशन एनर्जी का नाम हम लोग देंगे. तो इसके बाद जब हम ऑसिलेशन एनर्जी बोलेंगे ना, आप समझ जाना कि ग्राउंड स्टेट में, मतलब इक्विलिब्रियम में पार्टिकल चुपचाप बैठेगा विदाउट ऑसिलेशन. जितना एनर्जी पोजेस करेगा, ऑसिलेट करते हुए उसके पास जितना ज्यादा एनर्जी होगा, अगर ग्राउंड स्टेट में उसके पास एनर्जी E0 है, जब तो इक्विलिब्रियम में चुपचाप बैठा है, और ऑसिलेशन करते हुए उसका एनर्जी अगर E है, तो E minus E0 will be treated as the oscillation energy. This much of energy the particle needed, in fact, to start oscillation. तो ये तो रेस्टोरिंग फोर्स प्रोवाइडर तो वो एनर्जी नहीं देगा अपने आप, ग्रेविटेशन तो अपने आप नहीं देगा. ऑसिलेटिंग सिस्टम भी अपने आप कहां से एनर्जी लेके वो शुरू नहीं कर सकता. तो फिर दिस एनर्जी इज टू बी प्रोवाइडेड बाय द थर्ड एजेंट हु इज द एनर्जी ऑफ ऑसिलेशन प्रोवाइडर. ही मस्ट बी देयर आल्सो. But how this energy provider is associated with the system? You see, what he should do? He should come, give a sudden jerk. In the language of science, we say provide an impulse. What is an impulse? You know, impulse is a large change in momentum taking place in a small time interval. That is what we call the impulse. So practically, through a large force, वो थर्ड एजेंट थोड़े ही देर में उसका मोमेंटम को चेंज कर देगा और उसके पास कुछ एनर्जी डाल देगा, और इंस्टेंटली छोटा ही टाइम इंटरवल के अंदर वो एनर्जी डाल के फिर वो विथड्रॉ कर जाएगा चुपचाप. वो जोड़ के नहीं रहेगा ऑसिलेशन बॉडी के साथ. फिर वो एनर्जी मिल गया, ऑसिलेटिंग बॉडी ऑसिलेट करने लगेगा. आप पहले इस चीज को विजुअलाइज करो. दिस इज द मोस्ट फंडामेंटल थिंग who are needed to oscillate. You see, once the energy is provided, the energy provider is no longer in association with the system. He is no longer interacting with the system. Only this restoring force provider is interacting. So while oscillation is taking place, oscillating system and restoring force provider both are coupled. That coupling, if you break, oscillation will stop, because no longer there will be restoring force. This is the reason why whenever oscillation goes on, the oscillation time period, which is one of the characteristics of oscillation, is not decided by the oscillating system alone. The time period is decided by the oscillating system as well as the restoring force provider. If you recall, the time period of oscillation of the simple pendulum is 2 pi root over L by G. Do you remember this formula?
Yes.
You look at what is this L? What is this L? L is the characteristic of simple pendulum. But what is G? G, is it the characteristic of simple pendulum? No, it is the characteristic of the gravitational force who is playing the role of restoring force. In fact, what I mean to say is, what will be the time period of oscillation? That will not be decided alone by the oscillating system, but it is decided by the oscillating system and the coupling agent who is responsible for the restoring force taken together. But still, then also the oscillation is said to be a free oscillation. Why? Because for oscillation to take place, someone third agent has provided the energy. Neither restoring force provider has provided the energy, nor the oscillating system has provided the energy. Someone third agent has provided the energy. But what happened? The third agent who provided the energy, he provided the energy through initial jerk, and after that he left. He is not having any role. He is not forcing the system to oscillate with a time period of his own way. वो बोलता है मैं तुम्हारा टाइम पीरियड में कोई रोल निभाऊंगा नहीं, मैं बस ऑसिलेशन के लिए एनर्जी दे दिया और चला गया। तुम दोनों मिलके, तुम दोनों मतलब ऑसिलेटिंग सिस्टम और रेस्टोरिंग फोर्स प्रोवाइडर, तुम दोनों मिलके ऑसिलेट करते रहो और तुम्हारा अपना कैरेक्टरिस्टिक को तुम डिसाइड करो। ऑसिलेशन के लिए एनर्जी चाहिए, लेकिन एनर्जी देने वाला एजेंट तुम्हारा कैरेक्टरिस्टिक ऑफ ऑसिलेशन जो बेसिकली टाइम पीरियड होता है या फ्रीक्वेंसी होता है उसको डिसाइड नहीं करता है। इसीलिए बोला जाता है कि ऑसिलेटिंग सिस्टम एनर्जी लेने के बाद अपना टाइम पीरियड को अपने आप चुना रेस्टोरिंग फोर्स एजेंट के साथ मिलके। दैट इज व्हाई दिस इज कॉल्ड एज फ्री ऑसिलेशन। और एक तरह का ऑसिलेशन होता है जिसको बोला जाता है पोस्ट ऑसिलेशन। आप सुने होंगे क्लास 11 में। ये पोस्ट ऑसिलेशन कब होता है? जब ये एनर्जी प्रोवाइडर एनर्जी प्रोवाइड करते हुए ऑसिलेटिंग सिस्टम के साथ जोड़ के कपल्ड होके बैठ जाता है एक इंटरेक्शन के थ्रू। कपलिंग के लिए इंटरेक्शन चाहिए, कोई भी एक फोर्स को इन्वॉल्व करना पड़ेगा। वो एनर्जी प्रोवाइडर और ऑसिलेटिंग सिस्टम के बीच में कोई फोर्स परमानेंटली इन्वॉल्व होगा और वो इन्वॉल्वमेंट के थ्रू वो मजबूर करेगा इस ऑसिलेटिंग सिस्टम को कि तू तेरा वाला फ्रीक्वेंसी छोड़, मैं जिस फ्रीक्वेंसी में ऑसिलेट करने को बोल रहा हूं तो उसी फ्रीक्वेंसी में ऑसिलेट कर। नाउ द सिस्टम इज नॉट फ्री टू ऑसिलेट विथ ए फ्रीक्वेंसी चूजिंग बाय हिमसेल्फ along with the restoring force, but he is compelled to oscillate with a frequency which is decided by the external agent who is providing the energy continuously. That is why that is called as force. मैं आपको जबरदस्ती एक फ्रीक्वेंसी में ऑसिलेट करने के लिए बोलूंगा जो आप नहीं चाहते हो, तो फिर आप क्या बोलोगे? हम फोर्सफुली ऑसिलेट कर रहे हैं। लेकिन आपको मैं एनर्जी, जैसे मैं आपको कुछ पैसा दूंगा खर्च करने के लिए, जाओ खर्च करो अपने पसंद के मुताबिक, तो फिर वो फ्री स्पेंडिंग हुआ। लेकिन मैं तुमको एक पैसा कुछ दूंगा, उसके साथ एक लिस्ट पकड़ा दूंगा कि इसी के हिसाब से तुमको ही खर्च करना है। दैट इज फोर्स्ड स्पेंडिंग। आई फोर्स्ड यू टू स्पेंड इट इन ए पर्टिकुलर मैनर ओनली। सो बेसिक लेमैन अंडरस्टैंडिंग द डिफरेंस बिटवीन free oscillation and forced oscillation is if the energy provider is permitting the system to oscillate with a frequency decided by the oscillating system and other who are coupling with it along with the oscillation, then oscillation is said to be free oscillation. And the oscillation in which the energy provider is coupled with the system and compelling the system to oscillate with his own frequency, then this oscillation is said to be forced oscillation. We will discuss about forced oscillation. You know, oscillation, whenever is mathematically expressed, we need the use of periodic functions, as I will show you in future classes. Periodic functions. In mathematics, you read about periodic functions, the functions that repeat itself after equal intervals of the independent variable. These periodic functions in mathematics are also called as harmonic functions. Because oscillations always involve harmonic functions for their complete understanding, complete, understanding the situation. That is why many times these oscillations are also called as harmonic motions because they involve periodic functions in their equations. Now, if oscillation is freely done, it is free oscillation or free harmonic motion. If it is done forcefully, I have already explained what is forced oscillation, then the oscillation is said to be forced harmonic oscillation. Any entity who is oscillating is an oscillator. Any entity who is oscillating is an oscillator. So you might be now following what is the difference between free harmonic oscillator and forced harmonic oscillator. This free harmonic oscillation is also divided into two categories. One is damped, undamped, another is damped. What is the meaning of undamped? What is the meaning of damped? That I am going to explain. But before that, let me characterize any oscillation. What are the quantities by which one oscillation is distinguished from the other? There are many such quantities. We will learn about them one by one. First one is time period. That is one characteristic. Characteristics of oscillation. Any oscillation. Soon I will give you note. Very soon I will upload note. I have today uploaded the course handout. You go through it, and whatever I am providing, you please download it and keep it with you. That is the thing that you may be referring many times while appearing the examinations and understanding. One
Sir,
yes.
Sir, if two or more pendulums are connected from a same hinge, and then it is oscillated, then it is seen that the pendulum at the extreme right and extreme left only oscillates. So, sir, what is the reason behind that, and is it a oscillation?
See, whether these two pendulums are coupled through an interaction or not. When you are saying, suppose two pendulums are suspended from this same, I mean, you told it hinge. Okay, I accept it as a hinge.
So it is from the same hinge only.
Same hinge means here. You mean?
No.
What do you mean by same hinge?
So from the same point, two pendulums are.
Okay, from the same point, two pendulums are there.
Yes, two or more pendulums.
Then one will go and like this come, another will go and like this come.
Sir, is it an oscillation?
You see, this is a to and fro motion.
Yes, sir.
This is periodic.
Yes, sir.
So it is oscillation. Now, whether you can call it simple harmonic oscillation or not, that's a separate question. That can be understood once we understand how the simple harmonic motion is distinguished from the normal oscillations. You can think of many types of oscillations in nature. All of them are not simple harmonic. We will focus mostly on simple harmonic motions. Why? I will tell you the reason in due course of time. But that does not mean that we cannot attack to any complex oscillation. Any oscillation which is not simple harmonic is said to be complex. Now, second thing is whether we are going to see the oscillation of one entity only, or we are going to see the oscillation of many entities coupled with each other by some interaction. When we, in fact, oscillate a system whose one part is coupled with other part, suppose I want to oscillate this one only. But whenever I provide energy to this to oscillate now, through the coupling action, this will be oscillated, this will be oscillated, this will be oscillated. In that case, this alone cannot decide the characteristics of oscillation, the time period, the frequency, the amplitude. When you disturb a metal at one place, the whole metal starts oscillating. So in that case, what will be the frequency? That is not decided by the component of the metal to which you provided the energy. It rather is decided by the coupling action between all the components as well as the components themselves together. those type of oscillations are called as coupled oscillations. So we will discuss about coupled oscillations very, we can say we will peep in into the oscillation only. We will not go to the very detail of coupled oscillation. We will have a small example of coupled oscillation, which itself appears to be one long question and a very prominent question in mid-sem examination. Is it okay?
Yes, sir.
Okay. Now coming to what are the characteristics of oscillation. First characteristic I told you, time period, and second is frequency. I need not have to explain what is time period and what is frequency. Some more characteristics. Every oscillation has an equilibrium position. That is another characteristic. Now,
Amplitude.
there are two experiments. The distance of one experiment from the equilibrium position is said to be one amplitude. Another one is called 2 second amplitude. An oscillation may have two different amplitudes. The left amplitude and right amplitude, or top amplitude and bottom amplitude, they need not be same. They may be different. But if they are equal, we say they have a common amplitude. That is what happens many times, but not necessary. In many oscillations, we see the amplitudes are different. When amplitudes are different, left amplitude and right amplitudes are equal, with that we say that to be an isotropic oscillation or symmetric oscillation. Whereas if A1 is not equal to A2, then oscillation is anisotropic. In that case, that oscillator is said to be anisotropic oscillator. You know, whenever you strike a metal vessel, आपके पास कोई मेटल का वेसल है, घर में देखे होंगे, ब्रोंज का कोई वेसल है, उसको एक जगह पे थोड़ा सा स्ट्राइक कर दो तो पूरा वेसल मतलब ट्रेम्बल करने लगता है. तो वो जो ट्रेम्बल होता है वो क्यों होता है? बिकॉज ऑल द मॉलिक्यूल्स इन इट और पार्टिकल्स एटम्स इन इट दे स्टार्ट ऑसिलेटिंग. Sometimes they get closer, then they go far away, and these oscillations are normally anisotropic. They are not isotropic. If you oscillate a molecule like water molecule, if you are oscillating, or a carbon dioxide or carbon monoxide oscillating molecule you are oscillating, because molecular oscillations produce spectrum, and these spectrum first were elaborately discussed by C.V. Raman, because of which he got the Nobel Prize. You know, he could correlate the spectrum obtained with the vibration or oscillation of the molecules. If anyone is interested, you can go to that. But I don't think that is of any use in computer science and engineering. It may be your hobby, but cannot be a professional knowledge. तो ये जो oscillation हो रहा है, ये ऑसिलेशन जो दुनिया में देखते हैं, इनमें से काफी ऑसिलेशन अनाइसोट्रोपिक है. वेरी फ्यू ऑसिलेशंस आर ओनली आइसोट्रोपिक. बट व्हाट यू विल बी डिस्कसिंग इन आवर स्मॉल पार्ट ऑफ फिजिक्स दैट यू विल बी रीडिंग हियर इज isotropic oscillation only. And very interestingly, any anisotropic oscillation can be considered as a superposition of large number of isotropic oscillations. That also can happen. There is mathematics behind it. We are not going to discuss all those things in detail. Till now, anyone having any question?
No, sir.
Okay. So we characterize, for the time being, we characterize an oscillation by few parameters: the time period, the frequency, the amplitude. Of course, you can say also the energy, but later on we will come to that. Okay. What I discussed here is, for any oscillation to be possible, a restoring force presence is essential. Without a restoring force, no oscillation can take place. Now the question comes. There are many forces present in nature. When I entered to class 7, class 8, I was told about forces and many types of forces. I was told about muscular force, I was told about frictional force, I was told about air resistance, I was told about viscous force, I was told about electric force, magnetic force, gravitational force, nuclear force, weak force, so many different type of forces. Can any force play the role of restoring force? कोई भी फोर्स किसी ऑसिलेशन में आके वो वहां पे बैठ के बोलेगा चल चल तू ऑसिलेट करना शुरू कर, मैं तेरे लिए रेस्टोरिंग फोर्स बन जाता हूं, क्या ये संभव है?
No, sir. No, sir.
No, sir.
तो इस टाइप का फोर्सेस ऑसिलेशन में रेस्टोरिंग फोर्स का रोल निभा सकते हैं.
Conservative.
Conservative forces. That is what I had also told you in my last class. So only the conservative forces can play the role of restoring forces, like your electric force, spring force, gravitational force. These are all conservative forces. To talk little bit about conservative forces, you must be knowing, I am just revising. A conservative force is one work done by which does not depend on the path followed. Now this is the mathematical definition of conservative force. But to a layman, what a conservative force means? To a layman, conservative force means a force moving under which or against which a system is not going to lose its energy to the surrounding. Here I want to give an example to understand the meaning for those who have not read it properly in 11th class. You think of a situation, I am having 1 lakh of rupees with me. So that is my property, 1 lakh of rupees. I can spend, I have to spend it, but I can spend it in two different ways. First way, what I did, I went to the gold shop, purchased gold for 1 lakh rupees. Now I spend the money, you must be following. I spent the money completely, 1 lakh rupees. But I did not lose the money value. Because the gold money value, that 1 lakh rupees money value is now with gold, and that gold is still with me. So I spent the money but did not lose the money value. Second situation. Suppose I took you all to the 5-star hotel. I'm not going to do that. But think of a situation. I took you all to the 5-star hotel. We sat together. We ate lunch. And after then, I paid the 1 lakh rupees to the hotel manager. There also I spent. But I lost the money value completely. It is no longer with me. But still, that lost money value is not destroyed. Why? Because that money value was little bit earlier with me. Now is with the manager. It is in my surrounding. It is not with me, but still it is in the surrounding. So it is in the universe. Universe means surrounding plus system. Similarly, when a system does work, he has to spend energy. Any work is always associated with exchange of energy, spend of energy. Now the question comes. A system is doing work against a force. He is spending energy, but he is losing it to the surrounding or not. You take an example. Suppose you threw a piece of stone to vertically upward against gravity. The stone at the time of throw had some energy, which is in the form of kinetic energy. As it went off, it had to do work against gravitational force. So its kinetic energy went on spending. So kinetic energy decreased. But what you will mark, the spent kinetic energy is not going to lose to the surrounding. It is still available in the stone, but in a different form, what we call as potential energy. So practically the system is doing work, but not losing energy to the surrounding. It is still with it. If this happens, the kinetic energy or any other form of energy is spent against a force, and the same energy spent reappears in the system in the form of potential energy, then the force is conservative force. So whenever a system moves under or against the action of a conservative force, you know, the system is not going to lose energy to the surrounding. But if a body is moving against or under the action of a force and losing energy to the surrounding continuously, लगातार, तो फिर सिस्टम का एनर्जी घट जाएगा, जबकि उतना अमाउंट का एनर्जी सराउंडिंग में अवेलेबल होगा. लेकिन बोथ केसेस में, चाहे कंजर्वेटिव फोर्स हो या नॉन कंजर्वेटिव फोर्स हो, बोथ केसेस में यूनिवर्स का एनर्जी नष्ट नहीं होगा, क्योंकि आइदर वो सिस्टम में रहे या सराउंडिंग में रहे, वो तो यूनिवर्स के अंदर है. लेकिन कंजर्वेटिव फोर्स के अगेंस्ट में जा रहा होगा तो उसका अपना एनर्जी जो है वो टोटली कंजर्व रहेगा. दैट इज व्हाई दिस फोर्स इज नेम्ड एज कंजर्वेटिव फोर्स. So now you understand the conservative force and non-conservative force distinction in the layman language. Conservative forces are the forces against which when a body moves, its total energy is conserved. It is not going to lose energy to the surrounding. Whenever energy is continuously lost to the surrounding, then we say the energy of the system is dissipating. So dissipation is a term that is associated with loss of energy to the surrounding. That does not mean destruction. I am losing. That does not mean that I am destroying. Destroying means conversion to nothing. I am dissipating, I am losing, but the same amount is appearing somewhere else. So, whenever a body moves against a conservative force, the amount of energy spent against the conservative force reappears in the same body but in a different form. So total energy is constant. But if the body moves against the action of such forces that the body will be continuously dissipating energy to the surrounding, then system's energy goes on decreasing continuously, and in that case system loses energy to the surrounding. But as a whole in the universe, the energy is still same, whether it is with the system or with the surrounding, it is in the universe. So in both the cases, energy of the universe is constant, but when the force is conservative, the energy of the system is conserved, and when the force is not conservative, the energy of the system is not conserved, but in both the cases, the energy of the universe is conserved. So energy conservation principle, whether you are applying to the system or you are applying to the universe, accordingly it is stated as. Any question on this?
No.
Okay. Now coming to oscillation. What I told that in any oscillation there must be a restoring force. Without the existence of restoring force, no oscillation is possible. And that restoring force must be an external force. That too, that restoring force is a conservative force. You cannot show me any example of oscillation in nature where a force playing the role of restoring force and is not conservative. No, that is not possible. No oscillation can be possible where the non-conservative force is playing the role of restoring force. So, the restoring force in any oscillation is conservative. Now think of a situation, an ideal situation, where except restoring force, there is no other force present. Think of a situation. Imagine, ideal. ओनली रेस्टोरिंग फोर्स ही प्रेजेंट है ऑसिलेशन के टाइम में जो चाहिए, दूसरा कोई भी फोर्स वहां पे ऑसिलेशन में प्रेजेंट नहीं है. ना फ्रिक्शन एयर मतलब इलेक्ट्रोमैग्नेटिक डैम्पिंग है, ना एयर रेजिस्टेंस है, ना फ्रिक्शन है, ना विस्कस है, कुछ नहीं है एक्सेप्टिंग रेस्टोरिंग फोर्स. तो होगा क्या? सिस्टम ऑसिलेशन के टाइम में उसका टोटल एनर्जी कंजर्व रहेगा, क्योंकि अभी हम बोले कि कंजर्वेटिव फोर्स के अगेंस्ट में या प्रभाव में मूव करते हुए सिस्टम का एनर्जी कभी डिसिपेट नहीं करता है. और मैं प्रूव करके दिखाऊंगा, जो प्लस 2 में भी आप पढ़े हैं, कि एनर्जी ऑफ ऑसिलेशन इज डायरेक्टली प्रोपोर्शनल टू एम्पलीट्यूड स्क्वायर. एक्चुअली एनर्जी का जो एक्सप्रेशन है ना, वो हाफ एम ओमेगा स्क्वायर एस स्क्वायर है. एम मास, ऑसिलेशन के टाइम में मास बदल नहीं रहा है. ओमेगा एंगुलर फ्रीक्वेंसी, जो कि फ्रीक्वेंसी के साथ रिलेटेड होता है 2 पाई एफ के द्वारा. मैं बताया हूं ये फ्रीक्वेंसी सिर्फ एंड सिर्फ डिपेंड करता है ऑसिलेटिंग सिस्टम और रेस्टोरिंग फोर्स के प्रोवाइडर के द्वारा. अगर कोई तीसरा फोर्स नहीं है तो ओनली रेस्टोरिंग फोर्स है. सो वंस यू चूज द ऑसिलेटिंग सिस्टम एंड यू चूज द रेस्टोरिंग फोर्स प्रोवाइडर, फ्रीक्वेंसी बिकम्स ए कांस्टेंट, एंगुलर फ्रीक्वेंसी बिकम्स ए कांस्टेंट. तो जो एनर्जी प्रोवाइड करेगा ऑसिलेशन के लिए वो कभी एम या ओमेगा को डिस्टर्ब नहीं कर सकता। वो डिस्टर्ब किसको करेगा? सिर्फ एंड सिर्फ एम्पलीट्यूड को, एम ओमेगा स्क्वायर, सिर्फ एंड सिर्फ एम्पलीट्यूड को। तो अगर रेस्टोरिंग फोर्स ही प्रेजेंट है जो कि कंजर्वेटिव है, तो सिस्टम का एनर्जी घटेगा नहीं, क्योंकि सिस्टम एनर्जी लॉस नहीं करेगा। इसका मतलब उसका एम्पलीट्यूड भी मरेगा नहीं, मतलब एम्पलीट्यूड डाई आउट नहीं करेगा, उसका वैल्यू डिक्रीज नहीं होगा। सो as long as the oscillating system is not dissipating energy to the surrounding, its amplitude will be maintained.
Yes,
When the amplitude is maintained, the oscillation is said to be undamped. जो ऑसिलेशन मर नहीं रहा है लगातार, स्लोली एंड स्लोली, उसको अनडैम्प्ड ऑसिलेशन बोला जाता है। लेकिन सोचो, रेस्टोरिंग फोर्स के साथ और एक फोर्स एयर रेजिस्टेंस जैसा भी प्रेजेंट है। एयर रेजिस्टेंस तो नॉन कंजर्वेटिव है, तो ऑसिलेशन के एनर्जी घटता जाएगा, क्योंकि एयर रेजिस्टेंस के अगेंस्ट में वर्क करना पड़ेगा, तो फिर उसका एम्पलीट्यूड भी घटता जाएगा। उसी को बोलते हैं डैम्प्ड ऑसिलेशन। नाउ यू अंडरस्टैंड, ये दोनों फ्री है, क्योंकि इसमें जो ऑसिलेशन का फ्रीक्वेंसी है वो एनर्जी प्रोवाइडर डिसाइड नहीं कर रहा है। पहला केस में रेस्टोरिंग फोर्स का सिस्टम मिलकर डिसाइड कर रहे हैं, सेकेंड केस में सिस्टम रेस्टोरिंग फोर्स प्रोवाइडर, और क्योंकि डैम्पिंग फोर्स भी आके जोड़ जाता है ना, वो भी अपना रोल थोड़ा प्ले कर लेता है फ्रीक्वेंसी डिसीजन में। इसलिए दोनों केस में फ्रीक्वेंसी सेम नहीं होगा, लेकिन दोनों केस में फ्रीक्वेंसी एक्सटर्नल एनर्जी प्रोवाइडर डिसाइड नहीं करेगा। इसीलिए दोनों केस को हम लोग फ्री ऑसिलेशन बोलेंगे, बट वन इज अनडैम्प्ड, अनदर इज डैम्प्ड, बिकॉज़ इन दिस केस द एम्पलीट्यूड गोज ऑन डिक्रीजिंग, बट एट व्हाट रेट? ऐसे तो बोल देने से नहीं होगा ना, हम लोगों को उसको क्वांटिफाई करना पड़ेगा, मैथमेटिकली उसको चेक करना पड़ेगा कि किस रेट में ये ऑसिलेशन घट रहा है, नहीं घट रहा है। ये सब बात को हम लोग मैथमेटिकली डिटेल्स देखेंगे। पहले मैं बेसिक एक स्ट्रक्चर आप लोगों को समझा देता हूं। इफ यू हैव एनी क्वेश्चन रिगार्डिंग दिस, यू कैन आस्क। एनी क्वेश्चन?
No, sir.
So we discussed about oscillation in general. We discussed about the free oscillation and forced oscillation in layman language. We discussed about the two types of free oscillation, undamped and damped oscillation. We discussed about when the oscillation is going to be damped. We discussed about the characteristics of oscillation. These are the parameters that we need always to distinguish one oscillation from the other. When damped oscillation will be there, there will be another characteristic that will decide what is the effect of damping. ये जो damping force अगर रहेगा, मतलब नॉन कंजर्वेटिव फोर्स प्रेजेंट करेगा, वही डैम्पिंग करा रहा है ना, इसलिए उस फोर्स को डैम्पिंग फोर्स या डिसिपेटिव फोर्स भी बोला जाता है। तो डैम्पिंग फोर्स जब एसोसिएटेड रहेगा, कितना डैम्पिंग रहता है, उसका असर कितना है एम्पलीट्यूड घटने में, लगातार एनर्जी डिसिपेटेड होने में, उसको समझने के लिए एक पैरामीटर को यहाँ घुसाना पड़ेगा, तो वो भी कैरेक्टरिस्टिक ऑफ द ऑसिलेशन में चला आएगा। तो इस तरह आहिस्ता आहिस्ता हम कैरेक्टरिस्टिक ऑफ ऑसिलेशंस को आइडेंटिफाई करने लगेंगे और उसके साथ ऑसिलेशन को क्वांटिफाई करना शुरू कर देंगे। नेक्स्ट क्लास में हम आपको सिंपल हार्मोनिक ऑसिलेशन और इक्वेशन ऑफ मोशन के बारे में बोलेंगे, जो कि सबसे इंपॉर्टेंट बात है। व्हाट इज द मीनिंग ऑफ इक्वेशन ऑफ मोशन एंड व्हाई वी आर गोइंग टू यूज अबाउट इक्वेशन ऑफ मोशन concept in oscillations, whether it is free undamped or it is free damped or it is forced oscillation. All these three things we will discuss. Any question if you have from your side, I welcome. Otherwise, today's class I want to keep here.
Yes, sir.
Yes, sir. No question, sir.
No question, sir.
Yes.
Thank you, sir.
Okay. Thank you all. Then I want to